Guys, welcome to my channel. Keep calm and love maths. This is part 2. In the previous part, I have discussed about relation and some terms. Now I am going to discuss the types. If you have not watched my first video, then go through it so that we can understand this. So let's proceed. Here, the types. The first one is empty relation. Type 1, empty relation. The definition is a binary relation R in a set A is called an empty relation in A if no element of A is related to any element of A. That is, if R equal to 5. So, this means a binary relation R in a set A is called an empty relation in A. That means binary relation means R from set A to A itself. This R will be called an empty relation if no element of A related to any element of A. That means when R equal to 5, that is R contains no element. In this case, we can say R is an empty relation. For example, if we take the set of boys in a school, the relation which is defined as ordered pair A comma B such that A is a sister of B. The ordered pair is like that A is sister of B is an empty relation. In this case, this relation is an empty relation. How? I am explaining. In a school, the set of boys mean that the set contains boys only, but the relation is A is sister of B, where A is a girl. In the set of boys, this is not a relevant element. So, for the set of boys in a school, the relation this is an empty relation. This set is an empty relation regarding this set of boys in a school. And the second example is the relation that is ordered pair A comma B such that A is negative of B is an empty relation in the set of natural numbers. First of all, you already know what is natural number. Natural numbers start from 1, 2, 3 up to infinite. So the relation ordered pair A comma B such that A is negative of B in the set of natural numbers. Do you have any negative number? No, right? So A is negative of B. This relation cannot be, this relation contains no element. Therefore, the relation AB such that A is negative of B in the set of natural numbers, it is an empty relation. So guys, have you understood this? If you do not understand, then let me know in the comment section. Now proceeding to the second type, that is universal relation. Universal relation definition is a binary relation R. A binary relation R in a set A is called an universal relation if each element of A is related to each element of A. That is R equal to A cross A. Here the universal relation R will be Cartesian product of the set A itself. That means R equal to A cross A. Here the example, the relation that is ordered pair A comma B such that A plus B belongs to N. A plus B belongs to N is an universal relation in N. This is very obvious because sum of two natural number is also a natural number. Hence, this relation could be an example of universal relation. Now the type 3. A relation R in a set A is said to be reflexive. A relation R in a set A is said to be reflexive if the element in the form A comma A belongs to R for all A and B belongs to A. That is, the relation R is called reflexive when this relation R contains the element in the form A comma A. The number 2, symmetric. The relation R will be called symmetric relation if for an element a comma b belongs to R. It implies that there is another element b comma a belongs to R for all a comma b belongs to A. That is, the relation R is said to be symmetric if for an element a comma b belongs to R. If this implies that there is another element BA belongs to R, then this relation is called symmetric. Now the third one, that is transitive. A relation R in a set A is said to be transitive if here two elements which will be given. If A comma B and B comma C belongs to R, then these two elements imply AC belongs to R for each element A, B, C belongs to A. When there are two elements given in a relation, that is, one element is AB and the another is BC belongs to R, then these two elements imply that there is also another element AC belongs to R, then this relation will be called transitive for each element ABC belongs to A. So let's take an example. That is, let us take a set A which contains 1, 2, 3. The set contains 1, 2, 3 only. Then suppose we define three relations on the set A, R1, R2 and R3. We define three relations R1, R2 and R3 in the set A. Then if we take R1 equal to 1, 1, 2, 2 and 3, 3. The relation R1 contains the element in the form 1, 1, 2, 2 and 3, 3. Then this R1 is called reflexive. That is, R1 contains the element 1, 1, 2, 2 and 3, 3. Then it is reflexive for all 1, 2, 3 belonging to the set A. Then let R2 equal to 1, 2, 1, 3, 2, 3, 2, 1, 3, 1, 3, 2. Let us suppose that R2 is a relation in a way that R2 equal to 1, 2, 1, 3, 2, 3, 2, 1, 3, 1, 3, 2 for all the elements in the set A. Then this is called symmetric. How? Because by definition of symmetric, if AB belongs to a relation, then it implies what? BA belongs to R. So here 1, 2 implies 2, 1, right? 1, 2 implies 2, 1. Similarly, 1, 3 element implies 3, 1. And the third one, 2, 3 implies 3, 2. So R2 is a relation which is called symmetric for all elements 1, 2 and 3 belonging to A. Now the third relation is such that R3 equal to 1, 2, 2, 3, 1, 3, 2, 1 and 1, 1. I have taken R3 as it contains 1, 2, 2, 3, 1, 3, 2, 1 and 1, 1. By definition of transitive, we have already discussed that when two elements AB and BC belongs to R, then the third element is in the form AC. When AB, BC belongs to R, then it implies there is another element AC belongs to R. Now you will see here 1, 2, 1, 2, 2, 3. That means A, B, B, C. Now it should imply an element AC which is 1, 3. So this is satisfied. Now for the another one. Now 1, 2, 2, 1. The two elements 1, 2. One element is 1, 2 and the another is 2, 1. It should imply 1, 1 which is this 1, 1. Therefore another pair is for the elements 1, 2 and 2, 1 belongs to the relation, this implies 1, 1 also belonging to the relation. Therefore, this whole R3 is a relation which is called transitive. So I think you have understood what is symmetric, reflexive and transitive relations. Now there is another relation which is called equivalence relation, and this is very interesting because an equivalence relation is a relation which satisfies all these three. That means a relation R which satisfies symmetric, reflexive and transitive, then this relation is called equivalence relation. Here you can see the definition. So this is the example of equivalence relation, which is the relation R AB such that A and B belongs to Z. Z means set of integers, and A minus B is divisible by 2. Then this is an equivalence relation. We have to prove this. The relation R equal to ordered pair A comma B such that AB belongs to integer, set of integers, and A minus B is divisible by 2, which is an equivalence relation. Now to prove this to be equivalence, first of all we have to see whether it is reflexive, whether it is symmetric, whether it is transitive. If this relation satisfies all these three, then we can say only R is an equivalence relation. Now let's come to first reflexive part. Reflexive. For an element A belongs to Z, A minus A equal to 0. Everybody knows A minus A equal to 0, but 0 is an integer, right? Therefore A comma A belongs to R, and here A minus A equal to 0 belongs to Z, and also 0 is divisible by 2. So we can say A comma A, this is an element belonging to this relation R, and if a relation contains an element in this form, then this is called reflexive. Now symmetry. Let us take A and B belongs to the set of integers. Now let A minus B belongs to R. We have already taken that A comma B belongs to R. We have already taken that A comma B belongs to this relation. Now according to the definition of R in the question, here A minus B is divisible by 2. I have written that, which is divisible by 2. Then if A minus B is divisible by 2, that means B minus A is also divisible by 2, because B minus A is nothing but negative of A minus B. So B minus A belongs to Z and it is divisible by 2. Therefore the element BA belongs to the relation R. So when an element A comma B belongs to R, it implies that BA also belonging to relation R. Therefore this relation is called symmetric. Now to check transitivity, let us take two elements A comma B and B comma C belongs to R. Since we have to prove the third element AC belongs to R, therefore we have taken this A minus C, and A minus C can be written as sum of these two, that is A minus C equal to A minus B plus B minus C. And since A minus B belongs to Z and B minus C also belongs to Z, then sum of these two also belongs to Z. In other words, A minus C belongs to Z. In other words, A minus C belongs to Z. Now, since this is divisible by 2 and also this is divisible by 2, then sum of these two also will be divisible by 2. Therefore, A minus C is divisible by 2. Finally, we have concluded that A minus C belongs to Z and A minus C is divisible by 2 for all A, B and C belongs to the set. Therefore, this relation R is called transitive. Now let's come to the question, which is R equal to AB such that AB belongs to Z and A minus B is divisible by 2. We have already proved that R is symmetric, R is reflexive and R is transitive. We know that a relation R which satisfies all these relations, then this is called equivalence relation. Hence, we have proved that R is an equivalence relation. So that's all about my class. What we have learned today: types of relation, empty relation, universal relation, reflexive, symmetric, transitive and equivalence relation. So if you have not subscribed to my channel yet, then you can subscribe to my channel to stay updated. Stay at home, stay safe. Thank you for watching my video.